Okay, we're going to write equations today, and today as we write equations, we're going to look at how we write equations for parallel and perpendicular lines. We applied the same process. We're still trying to find slope, we're still trying to find intercept, but we're going to apply our knowledge of what parallel and perpendicular lines look like. So let's just get started by graphing some lines and determining what makes lines parallel. So as we do that, why don't you take the time to graph these two sets of lines and put them on the coordinate planes here, and when you're ready, check, restart the video and check to see how you did. So taking a look at the first two equations, I solved both of those for y to get them in slope-intercept form, and then I graphed the first one in red using intercept of 2, slope of 2, so up 2 over 1. The other equation, I got y equals 7 minus 2x after subtracting 2x from both sides. Intercept of 7, slope negative 2 over 1. So these ones are not parallel. Because as you can see, the lines intersect. So they can't be parallel. Number 2, those are parallel, and we'll take a look at that in just a moment. But those lines do not intersect or cross anywhere. I solved the first one in blue by subtracting 4 from both sides. Negative x minus 4 equals y. Intercept negative 4, down 1 over 1. And the line in black, I subtracted 3x and divided by 3. Get y equals 5/3 minus x. So starting at 5/3, 1 2/3, down 1 over 1. And we can see that the lines do not cross. So what makes them parallel? Well, the lines slope in the same manner. And if they slope in the same manner, they're never going to intersect. So as you can see, their slopes are both negative 1. And if the slopes are the same, they will be parallel. The slopes in the first two were negative 2 and positive 2. Since they had different slopes, they will intersect at some point. So let's put that down in writing. If two non-vertical lines in the same plane have the same slope, then they are parallel. And the converse of that, if two non-vertical lines in the same plane are parallel, then they will have the same slope. So let's take a look at how we can write an equation for this now. Let's say a line passes through the point negative 3, negative 5, and is parallel to the line y equals 3x minus 1. How do we write an equation for that? Well, we've got to find slope and we got to find y-intercept in order to write an equation. So let's visualize that and see what we're talking about. It'll help to see what we're looking at, and then we can write the equation. Okay, so we go on to Desmos, and I plot the point negative 3, negative 5. My equation y equals 3x minus 1. And I want to find an equation for a line that's going to be parallel to the line in blue. That's the equation that we're looking at. So this line is going to look something like this. It's going to have a line that's parallel, that doesn't intersect. So if we're looking at it visually, we can look on the graph and figure out, well, I've got to have the same slope. Okay? Because parallel lines have the same slope. So the slope of the blue line is 3. This slope is 3. So I know the line that I'm looking for should have a slope of 3 also. Now I also need to find the y-intercept. Well, I can find the y-intercept on the graph if I know that my line has a slope of 3. So let's find the exact line instead of just sketching it. So if I start at my point negative 3, negative 5, and if I want to slope up 3 over 1, I can find a new point. Go up another 3 units and over 1. Up 3 units and over 1. I can keep doing that as long as I have a graph. And then if I draw the line exactly, I can find my intercept. Can you see the intercept? It's right here. 1, 2, 3, 0, 4. So that finds the intercept. So my equation for a line parallel to y equals 3x minus 1 would be y equals 3x plus 4. Okay? So if you have a graph and can visualize and understand what's going on, you might be able to find the intercept exactly. Sometimes you might not be able to find the intercept exactly because when you calculate the slope from the point, it might not come out exact as an integer. So sometimes we need to use the algebraic method. So we start off with our equation, y equals mx plus b, and we fill in what we know. Well, we know that the slope is 3. So I can put y equals 3x plus b. And let's pretend that we don't know this intercept yet. Okay? So what we do know is that we have this point at -3, -5. And that's an ordered pair, an x, y. So if I take the x and the y and I substitute those into the equation, so put -5 in for y and -3 in for x, now I've got an equation that I can solve for b. So I simplify -9 plus b and add 9 to both sides to get b by itself. So I get b is 4. So if I know my b value is 4, I can rewrite my equation. Y equals 3x plus 4. Okay, so that's two methods for writing an equation of a parallel line. You can either use the graph or we can solve it algebraically. So you should be able to do it both ways or understand how to do that both ways. Okay, let's take a look now at another set of lines. Why don't you graph those two lines, pause the video, and restart it when you're ready to take a look. All right, so what do you notice about these lines? You notice that they are not parallel. Their slopes are different, so they cross and intersect at a point. And the point that they intersect at forms a right angle. So these would be perpendicular lines. Okay? Perpendicular lines meet at a right angle. You'll learn more about that in geometry. But let's look at the algebraic aspect of it today. So perpendicular lines. When we talk about perpendicular lines, their slopes are going to be opposite reciprocals. So this slope is -2/3. This slope is 3/2. -2/3 and 3/2 are opposite reciprocals, meaning that one's positive, one's negative, and they are reciprocals of each other. The numerator and denominators are flipped. And when I multiply the two slopes together, I get -1. So those properties are true of perpendicular lines. So slopes that are opposite reciprocals, and if they have opposite reciprocals, they are perpendicular. The converse is also true. If two non-vertical lines in the same plane are perpendicular, then their slopes are opposite reciprocals. Okay, so let's do some practice now. Find an equation of a line that passes through 4, -5, and is now perpendicular to the line y equals 2x plus 3. Same as always, we got to find the slope and the y-intercept, and then we'll be good about finding an equation. So once again, let's take a look at it graphically to understand what's going on, and then we'll solve it graphically and algebraically. All right, so we're going through the point 4, -5, and it's got to be perpendicular to the equation y equals 2x plus 3. So if we sketch what it's going to look like, it should be something like this. And we're going to have perpendicular lines, and the slopes should be opposite reciprocals. So if the slopes are opposite reciprocals, we can take a look on a graph and see what's going on. So the slope of the original line, slope of this line is 2. That's the coefficient of x. And I can see on the graph going up 2 over 1. So an opposite reciprocal would be negative 1 over 2. So if I take a look on the graph, now to find our exact intercept, I should go down 1 over 2. Down 1 over 2. I'm going further away from the y-axis. I need to reverse it. Over 2, up 1. Over 2, up 1. And I can connect the dots and see where my y-intercept is. At 0, negative 3. So I can tell my intercept will be negative 3. So my equation should be y equals negative half x minus 3 for a line perpendicular to y equals 2x plus 3. Now it just so happens that the intercepts are opposites of each other. That's not always true. Let's work through this algebraically now. So if I start off with my equation y equals mx plus b, I fill in what I know. Well, since it's perpendicular to that equation, we said our slope is the opposite reciprocal of 2. So our slope is negative half. So y equals negative half x plus b. And then it goes through for negative 5. That's an x and a y coordinate. So we can plug in negative 5 for y. Plug in 4 for x. Now solve for b. So simplify. Solve for b. And we get negative 3 just like we got graphically. Perfect. So then we can rewrite the equation y equals negative half x minus 3. So same thing either way. You should understand what you're doing on the graph and also be able to work through that algebraically. Okay, so we worked through solving, or actually graphing, parallel and perpendicular lines, finding that parallel lines have the same slope. Lines that are not parallel have different slopes. And when they're perpendicular, slopes are opposite reciprocals. And then being able to use that to write equations. That's all the time we have. See you next time.